Welcome back, students. In my previous video, I discussed about the formation of images in case of spherical mirrors when we keep the object at different positions in front of it. Today we will discuss the problems related to the spherical mirrors. For that, first of all, we will understand the symbols that we are going to use for solving the problems. For height of object, we will be using h1. We can also use ho here. For height of image, it will be h2 or hi. U will be for distance of object from the pole of the mirror, while V will be the distance of image. F, focal length of the mirror, and M will be the magnification of the image. Notice one thing, all these symbols are small letters. Now we will see the formula that we are going to use for solving the problems. First is magnification, also called as linear magnification. It gives us the relationship between the size of image and size of object. Means whether our image is larger, smaller, or of the same size as that of object. So we can define it as ratio of height of image to height of object. We will understand linear magnification for concave mirror first of all. We know that formula for linear magnification is h2 upon h1. Now tell me, when will m be equal to 1? So it is quite obvious that if height of image and height of object are same, h2 and h1 are same, then m will be equal to 1. So for concave mirror, this is the condition when m is equal to 1, and this is the diagram that we have drawn for this condition. But notice one more thing here. Here image is inverted. Now whenever image is inverted, sign of magnification is always negative. That is why here we will say that m is equal to minus 1. Minus sign here is denoting that it is inverted image, and we know that every inverted image is real also. So minus sign tells us real and inverted image, and m is equal to 1 says that image and object are of the same size. Now let's see when will m be less than 1. So under what condition m will be less than 1? It is clear that if height of image is smaller than height of object, in that case m will be less than 1. But here also image is real and inverted, so we will say m is less than minus 1 here. So we have seen that for concave mirror m is equal to minus 1 or m is less than minus 1. Now the third condition is when m is greater than 1. Now here there are two possibilities which I have drawn here. Here image is enlarged but it is real and inverted. Here image is enlarged but it is virtual and erect. So we will say here m is greater than minus 1. Here m is greater than plus 1. So these are the three conditions for linear magnification of concave mirror. Now we will see for convex mirror. And for convex mirror there is only one possibility. Image is always diminished and image is always virtual and erect. So we will say that m is less than plus 1. Less than 1 means diminished, plus sign means virtual and erect. So from all these examples we have learnt, if the sign of m is positive, it means that image is virtual and erect. If sign of m is negative, it means image is real and inverted. So now we will see again the formula for magnification, which is h2 upon h1. But magnification can also be equal to minus image distance divided by object distance. Now this is a 3-in-1 formula because we can make 3 formulas out of this one formula. So I have written these two we have just seen, and the third one is h2 upon h1 will also be equal to minus v upon u. Our second formula is relation between radius of curvature and focal length of the mirror. And we know that focal length is half of the radius of curvature. We remember what is radius of curvature. It is the radius of that sphere of glass from which we have made the mirror. And we know that we cannot change the radius of curvature of a mirror. As a result, we cannot change the focal length of a mirror. It is always fixed. So our relation is F is equal to half of R. Third formula that we are using is mirror formula. It is the formula that gives us the relationship between three things, that is focal length, image distance and the object distance, and it is equal to 1 upon f is equal to 1 upon v plus 1 upon u. We have just seen that focal length of a mirror remains fixed. So out of the rest two, that is v and u, if one changes, other will automatically change. So now we have seen the formulas, but before we start solving the problems, we need to know these Cartesian sign rules. Let's understand these rules. First of all, our principal axis should always be drawn along the x-axis. So now we have plotted the graphs. We know that x-axis is a horizontal line. So our principal axis should always be a horizontal line which is along the x-axis. Second rule is that we will take the pole of the mirror as the origin, which means that every distance that we are going to measure will be measured from the pole of the mirror. Next point is that our object should always be kept towards the left side of the mirror. And if our object is on the left side, obviously the rays will start from the object. So our incident rays will always start from the object and they will move towards the pole. Now the next rule is, if we are measuring any distance in the direction of the incident light, it will be positive, and against the direction of incident light will be negative. Now because we are measuring every distance from the pole, so from the pole, if we are measuring distance on the left side, it will be against the direction of incident light and it will be negative. And if we are measuring the distance towards the right of the pole, it will be towards the direction of incident light, so it will be positive. And simpler way to remember it is, we will just remember that from the pole towards the left will be negative, from the pole towards the right will be positive. Another important thing, if we are measuring distance above the principal axis at right angles or perpendicular to the principal axis, above or below. So above the principal axis it will be positive, and if we are measuring it below the principal axis, it will always be negative. So these 3-4 points we need to remember for solving our problems. Now based on these Cartesian sign rules, there are certain sign conventions that which sign we are going to take for all these quantities. So let's first see for concave mirror. For concave mirror, we know there are two possibilities. One possibility is that where real and inverted image is formed. I have made one diagram. And another possibility is that where virtual and erect image is formed. So I have made that diagram also. Now I'll consider both these conditions separately. First we will take this condition when image formed is real and inverted. For that, h1, which is, we know, height of object. Now it is above the principal axis and perpendicular to it, so it will be positive. h2 is below the principal axis, so it will be negative. u, it is towards the left side of the pole, so it will be negative. v is also towards the left side, so it is also negative. m is negative because it is inverted image, and f is also negative because this distance is f, which is also towards the left side. So we see all these are the signs for concave mirror for this diagram. Now for this condition, when image is virtual and erect, we will see height of object above the principal axis, positive. Height of image above the principal axis, positive. U is always towards the left, so it is always negative. Now in this case, V is towards the right of the mirror, so it will be positive. Magnification, it is erect image, so again it is positive. And focal length is still towards the left, so this is negative. So we see that for concave mirror, signs of H2, V and M can be negative also, they can be positive also. Now we will see for convex mirror. H1 is above the principal axis, positive. H2 is also above the principal axis, positive. U is towards the left side of the mirror, so it will be negative. Here V is towards the right side of the pole, so it is positive. M, positive because virtual and erect image, and F is also towards the right side, so it is also positive. So we can see that for convex mirror, except U, which is always negative, everything else is positive. So you can just remember it like this also, but it is always better to understand and then remember. So we have seen the sign conventions and we have already seen the formula which we are going to use for solving the numericals. Quick revision for the formula. First is f is equal to half of radius of curvature. Second is our mirror formula. And third is the formula for magnification. And most important than all these things is the sign conventions. If you remember the signs, only then you will be able to solve the problems. And my suggestion to you is you make a chart of these sign conventions and put it in front of you while you are solving the problems. And slowly you will remember on your own. So let's start with the numerical. This is our first numerical. Go through the statement. You can pause the video and read the statement. And the technique is read the statement at least 2-3 times and highlight the keywords. So the keywords are, it is a concave mirror, it is forming inverted image, object is at distance of 12 centimeter, image is twice as large as that of object, and we have to find where is the image formed. The next step is we will write all those things which are provided to us in this numerical. First is object distance, which is 12 centimeter, and we know that u is always negative, so we need to put the sign here, minus 12. Magnification is 2. It is clear from this line that image is twice as large. It means magnification is 2. But magnification can be positive. It can be negative. So to find out that magnification is positive or negative, we need to see the clue, which is this one. It is inverted image. Inverted image means magnification will be negative. So m is minus 2. And then we will write what do we need to find, which is v. Now we have to identify that formula in which all the three things appear, which is this formula, m is equal to minus v upon u. So we know m, we know u, v can be easily found from here. But we have to be very careful. While we are inserting the values, we have to remember to insert along with the sign. So u will be negative, and this negative will cancel each other. M is also negative, which will remain. So our answer will come in negative, which is minus 24 centimeter. We will see another numerical now. Read the statement again and highlight the keywords. Now it says, where should an object be placed? Means we have to find u. It is a concave mirror of focal length 20 centimeter, and we know that for concave mirror f is always negative. So we will put here f minus 20, forming a real image at a distance 60 centimeter from it. Now this 60 centimeter is the distance of image, that is v. But for concave mirror we know that v can be positive, v can be negative also. Now how to identify whether it is positive or negative? So we need to look for the keyword here, and here is our clue that it is a real image. And for concave mirror, remember, whenever real image is formed, it is always inverted and it is always towards the left side. And if it is on the left side, it means it is negative. So v is negative. We need to find u, and all the three things appear in mirror formula. We know f, we know v, easily we can find out u. You see now that solving the numericals is very easy, provided we use the signs carefully, whether it is positive or the negative sign. So we'll solve one more numerical now. An object 5 centimeter in length. Don't get confused by the word length. It is actually the height of the object, which is 5, and we know that h1 is always positive, so it will be plus 5 centimeter. It is placed at a distance of 20 centimeter, which is u, and it is minus 20 centimeter. In front of a convex mirror of radius of curvature 30 centimeter, and convex mirror always have a positive focal length and positive radius of curvature. So we will say that r is plus 30 centimeter. From radius of curvature we will find the focal length of this convex mirror, which will be 15 centimeter. So we have used this formula. Focal length is equal to half of radius of curvature, and our f comes out to be 15 centimeter. Now let's see what do we need to find. Find the position of the image, which means v has to be found. Nature of the image. For nature we will always find m, and size of the image, which will be h2. Means we need to find three things here: v, m and h2. Now we will first of all use mirror formula, and we will see that f we know, u also we know. From here easily v can be found. So putting all the values along with their signs carefully, we will calculate the value of v, which will come out to be plus 8.57 centimeter. So we have found one thing, that is position of the image. Now we come to the second thing, nature and size. First we will find the size. Now in this formula we will check v we know, u also we know, h1 also we know. So from this formula we can find out h2, which will come out to be 2.14 centimeters. So it is the size of the image. Now we have to find the nature of the image, which can be found from the value of m. M is equal to h2 upon h1. H2 is this, h1 is given. So we can easily find m from here. From the sign of m, whether it is positive or it is negative, we will find the nature. So positive sign means it is virtual and erect image. So the nature of the image will be virtual and erect, which we have found out from the sign of magnification. I hope you are getting some clarity about solving these problems. Let's take one more problem here. Read the statement and highlight the keywords. So we see that here we are given object of size 7 centimeter, which means height of object h1 is given, which is always positive. Remember to insert proper signs along with every value. It is placed at a distance of 27 centimeter, which will be negative, of a concave mirror of focal length 18. Because it is concave mirror, so f has to be negative. F is minus 18. At what distance from the mirror should a screen be placed? Now we know that wherever the screen will be, image will be formed there only. So indirectly they have told to find the distance of image. Means we need to find v, find the size h2 and nature m. So we need to find the three things v, h2 and m. Now we have to identify which formula can we use. See here we are given u, we are given f, and v has to be found. Using mirror formula we can easily find out v. Insert the values along with their signs accurately. So v will come out to be minus 54 centimeter. Now we will see from this formula, we know v also, we know u also, h1 also is given. So from here we can find height of image or size of image h2, which will be minus 14 centimeter. For the nature, we have to find m now, which is equal to h2 upon h1. So h2 is minus 14, h1 is 7, our m will be minus 2. Minus sign is telling us that it is an inverted image. So nature of the image will be real and inverted. So students, here more the problems you will solve, more confident you will become. So let's see one more problem. Find the distance at which an object should be placed in front of a concave mirror of focal length 10 centimeter if the real image is formed or if the virtual image is formed 20 centimeter from the mirror. Now there are two conditions given to us, real image and virtual image. We will solve for them separately. We are given the focal length, which is minus 10 because it is a concave mirror, so it will be same for both. Now for real image, we need to remember here that in a concave mirror, real image is always formed on the left side of the mirror, so it will be negative. So here v is minus 20, but a virtual image is formed on the right side of the mirror, so it will be plus 20. Only this step you have to do right, rest of the numericals will be right itself. We have to find u in both the cases. Using mirror formula, we will find u for both. Remember to insert the values very carefully along with their proper signs. For real image u is minus 20 and for virtual image u will be minus 6.6. Now there is one way to check whether your answer is coming correct or not. Remember u has to come in negative all the time. If your u is coming in positive, it means you have done something wrong. I hope children, now you are confident enough to solve the numericals yourself. Try your hands on this one. Read the statement, mark the keywords and then pause the video and solve it. So our keywords are, it is a spherical shaving mirror which is a concave mirror. Radius of curvature is 60 and focal length is 30. Because it is a concave mirror, so both these things will be negative. There, it is placed at a distance of 15 cm from his nose. We know that shaving mirror is used to see our face, which is the object. It means nose here is the object. So u is minus 15 cm. Find the position of the image v and magnification m. We need to find these two things. So once we have identified the things, now the things becomes easier using mirror formula where f and u are known. So we can easily find out v from here. For finding m, again we will use this formula where v and u are known quantities. So m can be easily found. Let's try one more. How far should an object be placed from the pole of a converging mirror of focal length 20 cm to form a real image of size exactly 1/4 of the size of the object? Here 1/4 is the magnification. Solve it by pausing the video. Let's now see the keywords. How far should an object be placed means we need to find u from the pole of a converging mirror, which is a concave mirror of focal length 20 cm. So f will be minus 20. Forms a real image of size 1/4 of the size of the object. So 1/4 is the magnification, and because it is a real image, so it will be negative. Now in this question, we are provided with these two things. If we use this formula, m is equal to minus v upon u, we know only m. V and u are unknown quantities. Here also we know only f and v and u are unknown quantities. Now in such situations where two quantities are unknown, we find one quantity in terms of other. For example, here we will put the value of magnification. Now v and u are left. As we need to find u for ultimately in the question, so we will find v in terms of u. Now this value of v will insert in the mirror formula and calculate u from here. So our u will come out to be minus 100 cm. So our next numerical. An object is placed at a distance of 30 cm from a convex mirror. The magnification produced is 1/2. Where should the object be placed to get a magnification of 1/3? Now I want to give you two clues here. Number one, focal length of a spherical mirror remains fixed, does not change. Number two, if the magnification changes, it means both the object distance as well as the image distance will change. So work on these two clues and pause the video and solve the numerical. So we'll see what is given. U is minus 30. As it is a convex mirror where always real and virtual image is formed. So our magnification will be plus 1/2, and using this formula we can find out V from here. Now we know V and we know U also. So from mirror formula we can find focal length, which will be plus 30. Now we are given if the magnification becomes 1/3, what will be U? As I have already told you, if magnification changes, U and V both will change. So again we will use this formula, m dash is equal to minus v dash upon u dash. I have used the terms dash because the same formula we are using for the second time in the same numerical. Here again the same problem as was there in the previous question. Both v and u are unknown. So we will find v in terms of u here and then insert this value of v in the mirror formula. So from here we can easily find out u, which will be minus 60 centimeter. So that is all for today. I suggest you to practice as many numericals as you can till you become expert. And if you haven't subscribed to my channel, please do so. Thank you.